So welcome to our unit on biochemistry, and we're going to look at some biochemistry that it's related to chemistry related to biology. In order to do that, we need to take a real quick look at some basics of chemistry. And first, I'd like to just remind you that, as you know, cells are the basic units of life. And comparable to that, if cells are the basic units of life, we have basic units of matter, and those are atoms. So we're going to introduce this section by discussing atoms. So we just said all matter is composed of atoms. They are very, very tiny particles. Just as all living things are composed of cells, all matter is composed of atoms, whether it's living, whether it's not living. Every bit of matter in the universe is made up of atoms. Atoms give matter its particulate nature, meaning matter is made of little particles, little pieces, small amounts. So here we have a bunch of sand. When we look through a microscope, we can see that they are made of little particles. Well, if we look at that sand even closer, we can see that it is made up of individual atoms. So atoms are, by definition, tiny particles that cannot be broken down. We're going to learn that atoms there are subatomic particles that make up atoms, but for the most part, they cannot be broken down easily. So here are some examples of atoms: hydrogen, oxygen, and carbon. The structure of this atom, this small particle that cannot be broken down, is basically as follows, and I'm sure you've seen this before. We have a nucleus where we have protons and neutrons, and then we have electrons outside the nucleus. And those are right there. They're much smaller. They're negatively charged. But I want you to definitely understand there are protons and neutrons in the nucleus, and there are electrons traveling around outside. That leads us to understanding exactly what a chemical bond is. A chemical bond is when we have either the sharing or the transferring of electrons between two different atoms. So here we have an atom and here we have an atom, and they are sharing their electrons. They can be shared equally or unequally, but for the most part, we're just going to look at the fact that electrons are what is involved in chemical bonds. A chemical reaction is the making or breaking of those chemical bonds. That gives us a chemical reaction. A compound, a chemical compound, is when we have two or more different types of atoms bonded together. So they will always have the same composition. For example, hydrogen peroxide involves 2 oxygen atoms and 2 hydrogen atoms. Always. Every compound of hydrogen peroxide will be in this composition: 2 oxygen atoms, or 2 oxygen atoms and 2 hydrogen atoms. Compounds are made by bonding different types of atoms together. So here we have a carbon and an oxygen. That gives us carbon monoxide. Here's water, an oxygen and 2 hydrogens. And those are all different compounds because they have different types of atoms bonded together. So I know you've heard the term molecule. What's that? A molecule is when we have 2 or more atoms that are bonded together, but they could be the same type of atom. So, for example, we have what we call diatomic molecules, where we have 2 of the exact same kind of atom, 2 oxygens bonded together. That would be called a molecule, but it wouldn't be called a compound. This is also a molecule. Here, it's got an oxygen and 2 hydrogens. It's water. So for a molecule, we have 2 or more atoms that are bonded together, but they can be the same type of atom. An element, what is that? Well, on the periodic table, we have all known elements represented on the periodic table. So when you see periodic tables, all of the elements that we know of are listed up there, arranged on the periodic table. Elements are substances that cannot be broken down. So elemental substances contain only one type of atom. Carbon, only one type of atom there, it's carbon. Whether it's in the form of a diamond or a graphite, it is carbon. And of course, for biology, we need to know the elements that are essential to life. So these 6 elements are all essential to every known organism, all organisms that we know of. Carbon is represented with a C. Hydrogen represented by an H, capital H. Oxygen represented by capital O. Nitrogen represented by capital N. Phosphorus, capital P. And sulfur, capital S. Those are the elements that are essential to life. If you would like to look at advanced topics, there's a whole bunch of them. Different types of chemical bonds, different types of chemical reactions, physical properties of some of the elements or molecules. How are elements named? How are molecules named? How do we write chemical formulas for various compounds? What are some of the most common elements on Earth? They are different than the elements that are found in living things sometimes. What are properties of subatomic particles? How do elements differ from each other chemically? And I'm sure you can think of even more interesting ideas to look into this topic further. So I look forward to seeing you in class, and we'll just see you later.